Good morning, everybody. My name is Matt Sump. Today here with me is Alex Zuniga from our applications department, and he'll be doing a bulk of the demo portions of the Mastercam. So a quick overview of what we'll be covering today. I'm going to do an overview of some of the topics, and then I'm also going to do a few quick tips and tricks before I pass it over to Alex. And then Alex will do demos of the 2021 new items, as well as some additional tips and tricks. We had a good amount sent to us from our various applications engineers, so we might run over. So let's get into it. I have a few slides on some new items. So the first slide I have here is we've improved solid chaining for 2021. Before, solid chaining would just pick up on the edges of the solid, but now it uses a spun profile version of the solid. So similar to the turn profile function in the wireframe commands that a lot of people do when they first open up a part in Lathe, it reads that right off the solid now. So you don't have to create that turn profile if you don't want to. You get the same sort of selection capability. And I know a lot of people do like to create the wireframe just to have it, but you can know that you don't have to now in 2021. And part of that change was we needed to add the option to have a dynamic chaining option, because before, when you would pick on solid or solid entities, it would always start at the beginning or the end of a particular edge of a solid. But now that you have that dynamic point, it works similar to how that does on the wireframe side, where you can select a start point at really any specific point along the edge. And this is one where we'll definitely get more in depth on the demo side with Alex. But overview is we've done a lot of improvements to the 3D tool support that we've had in Mastercam now for the past handful of versions. So there's a reselect location and a select name plane option in here now. So it just gives you more control over the connection points when you're mating different tool components together. And then we've also added, similarly with a dynamic option, for a fine adjustment to the compensation page. You know, before you had that corner, center, tip, or edge of a particular insert, but now, you know, if you have a specialized tool or a really small tool, you can fine tune that compensation point so that it calculates the tool path exactly the way that you want. And then we also now have multiple insert cutting definitions added. This is mainly to support what I'll talk about on my next slide. But, you know, there's a lot of lathe inserts out there now, especially like on the prime tools, where, you know, it might be able to cut in multiple directions, or there's multiple points on a given insert that have the ability to cut. So you can have different definitions within the same tool now, as opposed to before you would have to copy that tool and create a new compensation point and basically have a duplicate tool in there to accomplish the same task. So with that multiple support, we can now support multiple inserts in the same tool as well. And Alex will have a file on this, which we didn't cover in the previous general webinar, where, you know, they have these new multi-inserted tools. They're more designed around, you know, the Multis or Integrex style of machines with an upper B head, so then it can index the tool to different positions and reduce tool changes on a given job. We've also improved the lathe simulator. So before, there was a setting kind of buried in the control definition manager, because you would be verifying a part, or it would look good in backplot, and then you would take it to verify. And when it would do a retract or a reposition move, especially on the lathe C-axis group tool pass, it would show that it was wiping through the part. This setting has been fixed, and it now will display properly and verify. If you're getting anything like that, best piece of advice would be to call our tech support staff or email them, and they can walk you through how to get to this spot in Mastercam and fix it. The main thing I want to talk about here for the simulation enhancements is that if you have mill turn or a mill turn light machine environment, it now runs directly inside the Mastercam simulator. Before, it would pop open our, what I would call, legacy simulation that ran in even yet another window, where now the simulator will run in the same as you would get with regular Verify. And you can do like what you can on the mill side and switch between simulation and regular Verify, and even use the newer backplot if you want. But I know a lot of people still use the integrated backplot that's in the programming interface. And then you also get some of the tools that weren't available in that legacy simulator, such as the clipping planes or the model compare features that are in the simulator. And you still get the same stuff you used to get with Milterm, where you can see the spindle rotation and various features that it had before, because it's the same engine in the background. It's just now running inside the simulator interface. So we've done some enhancements to the Pickoff-Cutoff commands if you have a Swiss post. So we've done a webinar on this. Feel free to check it out on our YouTube channel. But a handful of versions ago, Mastercam started doing OEM support for all the different Swiss machine tool manufacturers for custom post processors specific to the machines. But part of the feedback we got there was that they handle, stock transfer and stock advance differently than a standard lathe. So if the post has the right logic in there, you'll get this slightly updated interface on how it calculates the cutoff coordinates as well as the tangent point when you're in the cutoff operation. So I have a slide there on what Alex is going to get into for the lathe custom threads, the solid work holding, the 3D tooling like I was talking about, and the tips and tricks. But before I pass it over to Alex, let me get into Mastercam here, and I'll show you a quick few tips that I had. So the first one I want to cover here, and this was a new feature, I believe in 2019 in Mastercam, was the section view feature. So if you look on your planes tab here, you have all your standard, WCS construction tool plane. You have the display, which we added that in as well. And then we have the section view. So a lot of people say, well, I have section view turned on, but it's not doing anything. And you also want to be mindful of the section view is going to be based off the XY plane of your given plane. So you can see I have a plane here called top view section, and the XY is splitting directly through the center of the part. But in order to get that to work, you want to make sure you go to your view tab here and make sure that the section view is turned on in blue. So once section view is turned on, then I can control whether or not I have that section view visible. So if I turn that on, this is especially handy in lathe, in that now if I go to, say, this groove tool path here, it will display a nice cutout, and instead of me trying to get in here and trying to rotate the model just right to see what that groove tool path is doing, I can now see it right from a top view here, and it gives me a nice clean look. This is handy as well if I go into my back plot here, I can turn on what's called the quick verify, and it'll give me a representation of the stock there, and I can run this groove tool path, and I can see the tool going in there, and it's nice and clean, and I don't have a solid in my way, or I don't have to turn the solid to translucent, and it's just a nice way to view the part as I'm programming in lathe. The next quick thing I want to talk about with this particular file is we have native prime turning support. So if any of you work with Sandvik or know of the Sandvik prime turning, I recommend Googling it. There's some good videos out there what it can do, but it was kind of revolutionary the same way that the dynamic style of machining was for mill, and that you can really get improved cycle time and tool life off these tool paths. And they're mainly designed around cutting away from the chuck. So this particular tool has an insert here where it'll cut off the backside. And my biggest recommendation here is that first you need to know if your parts are a good fit for it and that your equipment can handle it. And the best way to do that is to talk with your Sandvik rep, and they can recommend either setup applications, tool applications, depending on what materials you're working with, what tools from that library are viable for this. And, if you don't have a sub spindle, a tail stock can help a lot because, you don't want that material pulling out of the chuck. But we have all the parameters in there, and this has been updated. When this first came out, I believe in Mastercam 2018, Sandvik themselves were still learning on the different capabilities and use cases for these types of tool paths and style of cutting. And now that we have it in there, is we have all the different strategies, and they've been updated for the past couple versions, and it's really dialed in at this point. So I definitely recommend checking that out if you think you have an application for it. And we also support all the 3D tooling now for all these different tools that Sandvik has. So the next part I want to talk about, this is kind of an older style tool path, but just letting people know it's available, or if you've never tried it. But anytime you have a part that has a deep channel where maybe you would pet groove it or do different ways to get all that material out of there, and anytime you have this sort of shape, you can run into issues with having a lot of chips getting bound up, and you get that bird's nest going on. But if you use a button style tool, this was originally developed by a Mastercam customer that took one of our 2D dynamic mill tool paths and flipped it 90 degrees and used it on a lathe. But over the years, we've refined and fine-tuned it to handle these types of geometries. So a lot of people forget that this is in there. So I just wanted to give kind of like what I did with the prime turning, is that it's just another tool in the Mastercam toolbox to improve your workflow and process. And then the last one I want to talk about is more of just, I would guess, a theory and a workflow sort of discussion. So I have a part here. It's just, a C and Y axis lathe part, but this particular part, let's say the customer doesn't have a live tool lathe and you have to move this part, which is probably pretty common in a lot of shops, even if you do have a live tool lathe. Like this part's fairly large, so it might not even have enough stroke to get to all the different features. So it has to be turned, and then it has to be moved over to a piece of mill equipment and then back to the lathe equipment. So the real tip here is utilizing these stock models in Mastercam. And a lot of people are used to using stock models on the milling side, especially when you're 3D machining, to find out what material's left so you're not cutting any air, or you're making, you're not over engaging a particular finish tool path. But what I did here is I did all my rough turning. Then I create a stock model. Well, first I did a stock flip and then flip it around. And if I go to my planes here, or not planes, levels, I can turn on my stock flip part. So my part's flipped here and it's rough turned on both sides. And then what I can do is when I'm done with all my turning on the first op, I can create that stock model, and then I can create a machine group for my milling operations. And the real trick here is all I did was right click and use the copy function. So I just copied that stock model down into a milling group, and now I can start doing my milling tool pass. And my 3D model's turned off there. I think it's blanked, but I think you guys get the idea where I'm starting to do the milling ops. It's getting closer to my net shape, and I'm done with all my milling there. I milled out the windows. Now I have another stock model, and then I do the same workflow where I copy that stock model down into another turning group, and then I can do all my finished turn operations. I think when I get to these final turns here, I do another stock flip, and using the stock model too before and after a stock flip also helps as well, because then you get nice tracking of the stock, and you can see there that gray outline I have of my stock remaining. It really just helps the software track what material's left. And when I do, say, like my ID roughing here, and then even when I get to my final verify or simulator, I can do a nice verify, compare, and make sure that I got this part done complete. So like I said, it's just kind of a quick overview of what I would think is a good way to track stock, either between machine groups or even it was a C and Y axis lathe. I can just create those stock models after I do milling operations. But that's all I had. Pass it over to Alex here.
All right, everybody. My name is Alex Zuniga. Like Matt said, I'm one of the apps engineers here. I do a lot of tech support and training. So if you need anything, you can always email the tech department. Myself or anybody will definitely give you a hand. So what I'm going to talk about here in this first this first part file here is going to be the multi-insert tools that we're going to be working on. So just to kind of give you a little preview, you can see this on the back plot. You can see the whole tool here being used on this specific rotation. So let's go ahead and we're going to jump into the Lathe Tool Manager here. And in here, you can go ahead and right-click and say create 3D tool. I have the one here created, but I'm going to go ahead and start fresh, create an insert or two, and then come back to this. So you can name your tool whatever you would need to, give it the tool number, the offset, all that fun stuff. And then you would have to define your holders. So if I click on the open model folder, wherever you would store your particular model when you grab one, in this case, I have this mini turret here. And when I grab that, I can start selecting the sections of the holders that I would need. And then you can see right off the bat all the inserts are gone because now the holder is being defined as such. We can give this a multifunction. And we have to give this a machining connection. So I can click the white arrow down here. And then from here I can select the mating area. So right here would be the face that ends up going inside of the mating on top of the end of the turret there. So once you've got your holder defined and named and whatnot, you can go to your insert list and we can start creating inserts. So once I create an insert, it's going to bring up the same type of situation as we had with the holder. You go ahead and click on the open insert model and select that same file again. Since it's all put together, might as well select things that are made together. So I can go ahead and grab this insert here. We'll start with this DNMG style, and we can name it whatever we want. So I'll just go ahead and give it the ISO name there. And you can choose whether it be a threading insert or grooving or whatnot. It's just general turning in this case. Go ahead and hit the next slide down. And here's where you can define what kind of position or what this will be. So maybe this will be our left spindle finishing. We'll go ahead and select a corner radius. And based off of how this tool looks, you can define if it's a left or right. This would be a right-handed holder. You would think about it as such, based off of the direction of the insert. Our align to face and all our mating, it's already put together quite well, so we don't have to go through all this motion here. We can go straight to our cutting plane. So we can select a cutting plane here or define one as necessary. So I'm going to just go ahead and select the name plane. And we'll use our bottom plane because what we need is Z sticking upward to the face of the insert. So in this case, that would be our bottom plane. So if I say that and click the green check mark, sorry, I'll get the insert up direction showing right here. So that's looking pretty good. But now we notice that our profile of this holder is taking this into account, our grooving style holder over here. So I don't want that in there because if I start turning on a part, you're going to crash into the section and it's going to say you're crashing into it, even though the stock is not nowhere near where this insert will be. So we can define that in the next page down. Right here is this adjustment boundary. So if I click on that, I'm able to go ahead and just click these blue arrows here and the green arrow as well. We can shade that down to where we need a boundary to be shown. Now we can do the bottom section as well. Get rid of that section there. And when I hit the enter button, you see now that boundary is no longer corrupted in there by this grooving insert. So that looks good. We'll go ahead and define how this is going to be placed in the machine. So that would be horizontal, since this is a mill turn style. Right, comes out at 0. These will be our left side spindles. That all looks good there. And then we can define our corner. So I'll just go ahead and use this 2-edge deal. I'll select that edge and that edge. And there we go. That's set up there. If the model was off place for whatever reason, that would have centered it where it is at the moment. Cut and plunge direction is correct, because once this gets tilted over, we are going to be cutting this direction and plunging through this direction. Quadrant 1 looks good. And then we can start defining different edges. So like our side clearance, we can do that right there. That looks good. Then our height of that, we can do, I'll go ahead and select this guy here because it'll allow me to use an arc and then a point to define that height. So maybe like right there. If I make this a little translucent, you can see there's that boundary edge right there. Same thing on the end clearance. We can go ahead and define the edge here and then the width using the same functions. Arc and then point. So now that looks really good. Everything's all set, ready to go. The next page here would go ahead and just, adding the type of coolant you want happening, your speeds and feeds, all that fun stuff. So that extra, information you want to give it. If I say OK to this, that should save this current file as such. Let me go ahead and put the model back. You see now I have an insert. I have that style there. Everything's looking good. So now I can go ahead and create another insert here. If I say new insert, I can name this whatever I need. So we'll go ahead and do a CNMG. Go ahead and pick our model. I can pick this model again. And I'll select this insert over here, the opposite side. And in here, we basically keep going down the same stuff, the same options. And it's very intuitive. It behaves pretty well compared to some of our 3D stuff back in the past. I'll go ahead and select our corner radius again. Select the offset number, whichever you'd like. Left hand, right hand tool. This is right hand, left hand in this case. We can go to our position here. And right here, when you start getting into inserts, after you've defined the primary insert, which is the first one you do, instead of defining a cutting plane, you end up defining a rotation plane based off of where it is. So in this case, this is the same direction faced up, but if it was like this grooving insert down here, I could go down and select that rotation however I need. I could type in 90 or select a point, to catch that rotation. In this case, it's the same location. I can go ahead and hit enter, and you'll see the, oops, looks like I messed up that rotation already. We can just type in 0 here. That'll fix it. There we go. So there's your insert up direction. I can go ahead and create that boundary again to get rid of the grooving boundary there on the bottom section. Hit enter. Notice that these are grayed out. Your primary insert defined its mounting position, so there's a lot of things grayed out, but you could choose now if you wanted to use this on a right spindle, which I have another example of that in the future. Again, you would define your locations, your width, all that fun stuff. Once you start defining all that, you can hit the green check mark. And now you're set with that style. So you have now 2 different inserts you can work off of. Now, how does this apply inside of the toolpaths? So let me cancel out of this. When you are creating toolpaths, like I've got here, you would pick your, once you get into your toolpath menu, you would select your tool. And once your tool is inside of this section here, you can right click on the tool and you can select your cutting definition. So in this menu now, all the inserts that I've defined, I can go ahead and click on whichever specific one I'm using. And in this case, it was just the left spindle roughing that I've got. Right? So then you would go into your tool angle page and define the rotation of the B spindle. So when I backplot this, you can see there's that 95 degrees. It's a 95 degree because you want to make sure that 5 degree or so, they're built off of a tilt. If you look at it, they're all built at a tilt. So you can see right there, nice little face. And then you can see the other tools working in action here, like this grooving toolpath here. See, if I just rotated 90, this grooving toolpath wouldn't go in the correct direction. So these are all the same tools. Let me go ahead and run the simulation here. Oops, take the wrong one. And I've already got all my sinks and everything set to go on here, so I'm just going to go ahead and launch the simulation. All right, so here's my machine. I can go ahead and push play and fast forward this a little bit so that way it goes a little quicker. So there's the first insert. Right, it's going to go in face. And then because I have my sinks all set up, it doesn't come up to change up to the next section. So I can go ahead and I'm going to just fast forward through the roughing. So it's quicker. Oh, there we go. So then you see it flip that location there. So I'm going to go ahead and slow this down and push play. Let's go ahead and finish. And then when it's done finishing, it's going to come back to the retract area that I specified. And you can see the rotation there. And then on to the next toolpath. So it works really well. You're able to make it behave how you need. There's a threading insert. Go ahead and fast forward this section here. Here's your Pickoff. It's just a generic tool. But then the last section here brings out that other tool. So that last section was the roughing tool there. And Matt mentioned different inserts have different compensation points. So if I come to this final facing toolpath, which is on the sub spindle, when I went to select my insert cutting direction, I took the time to make a left spindle roughing and a right spindle roughing offset. So there's the difference right there. You don't have to go and create a whole nother tool, a whole nother holder and all of that. You can just use the same insert and create a different compensation point. So this one is based off, if I click the other one here, you can see this one here is your right spindle. If I go to the other one here, you got a left spindle situation going on. So when you change these, it will define that situation. So when you go to make these toolpaths and create the correct planes, it will run the correct spindle at the correct direction. So they're very intuitive. No matter what angle you change them at, typically the tip will follow suit properly as well. So depending on what spindle you're working on. It does work in the normal lathe as well, not just mill turn. If you have a lathe post, let me pull this out here. Find it. Oh, here we go. If you have a lathe post that supports these type of holders, this is a normal lathe seat. All right, there's no job setup in mill turn. But you can see I took the time, I used the same tool. You can run this in the lathe seat as well. So if your machine is capable of using these type of cutters and you have a normal lathe post, you can get them to work in there too. It's a pretty good deal. Saves you time on turn changes and whatnot, tool changes. All right, so that's a little bit about the lathe multi-inserts. We're going to go ahead and jump over to the lathe components for our chucks. So let me go ahead and grab that file real quick. Hang on a minute. So as Matt mentioned before, in mill turn, we're able to create chuck components now. So if you open up your machine definition in here, you can start defining chuck jaws, collet jaws now. That's the biggest one that people have been pushing for, and we finally got it. So once you get your Code Expert opened up in here, you can go to the component library, and that's going to open up another session of Mastercam. And once that session opens up, it's going to ask you if you're going to change units or not, because this is going to be a metric component. It'll open up the machine definition. And in here, you can start adding chuck groups and collet groups. So if you were to right-click in this area here and click on groups, right now I've already got a collet chuck and group selected, so they're already grayed out. But you would be able to open those now at that point. And then in here, you're able to grab these particular groups and create new chuck jaws and chucks. So if I wanted to add a chuck, I can go in here. And we can go from our parametric view to a solid entity instead. We can name this, for now, we can call this a test chuck. We can go to our components. And I have a folder here with chuck components, and there's my 10-inch 6-jaw chuck. Pick that step file. And I'll go ahead and select the chuck itself. Now from here, I can go ahead and choose which face I want to be our backside. We'll just pick this guy. And X seems to be running through that slot, so that's pretty good. You just want to make sure they're aligned through a slot. You can say OK. And most of the stuff gets pre-populated. The only thing that doesn't get is our channel depth. So that is a 3mm channel depth. So I'll just go ahead and add that on there. We'll go to our parameters. And in here, you can say allow through stock. You can choose the max spindle speed. Maybe we want a 2000 spindle speed on something that's big. It's depending on what you want. But again, you can see the preview. Everything's nice and defined. And say OK to that. So now you'll see there's my my test chuck right there. And I have it made previously, but you get the idea. In our collet groups, or I'm sorry, in our chuck jaw groups, we can go to our chuck jaw group and click on Add Chuck Jaws. So in here, instead of creating a parametric style generic jaw here, we can go to our section here and choose a solid entity. And we can select from a file. I'll pick that same file. And even though the jaws are reversed in here, I'm going to want to use the back sides of these jaws. So I'm going to go ahead and click that jaw. I'll click a back face. Any of these back faces will work. And what we need to do is make sure Z is sticking perpendicular to the view we want. So in this case, if I rotate 90 degrees this way, and I right click and say top view, this is what I want. So wherever Z is, that's what's going to be the flip side. So if I needed to work off of this side, I'd make sure Z is sticking the opposite direction. Say OK. And then you can display a boundary here, so you can see as it's spinning, this is what it'll look like, is your boundary. Then we can go to our parametrics here and choose a reference point. In this case, this is our reference point, so that looks pretty good right there. You know, if you wanted to chuck off of something else, if this was reversed, maybe this would be our reference point. So depending on what you're working with. You can give it a reference diameter. In this case, it's 3.5. We'll say OK. And that's pretty much it for the jaws. The collet, chuck, and group behave pretty much the same way. You would just go inside each one of these and create that chuck and whatnot. So you can go into the collet chuck, go into your solids, select the file. There's my collet chuck. Here's my back face. Everything looks good. That's pretty much the gist of it. You can give it the name, and most of these things get pre-populated, which is really nice. And then allow through stock, you can add that in there. I'll go ahead and hit the escape on this. Same thing goes for the collet. I'm just going to go ahead and go to the edit page for this. I selected my file for this collet and the alignment for this collet. And there's your boundary and your reference point. So it's really nice. It works really well. So if I go to a part that's brand new, which I got here, and I wanted to start my groups with those specific equipment, I can go to my job setup, and I can go to my work holding for my left and right spindles and add a work holding component. So here's that 10-inch 6-jaw chuck that I made previously. And I can do the same thing in the right spindle and do the collet. And we can go into the jaws and add jaws to each one. Do our hard jaws. And then we can do our collet. Oops. You want to make sure you're grabbing out of your component library and not your defaults, because this is, where we actually took the time to make these models. And you can override certain things like your speeds and feeds, your speeds for those chucks. We'll go ahead and do a continuous bar stock for now, just to kind of get you an idea of what's going on. We'll select our part geometry. I'll leave the stock and everything pretty generic. Stick out looks fine. You can pick a cutoff tool that we're going to be using for a pick off later on. We'll select our reference point. I wanted to clamp from right there. When it goes to pick off, and say OK. So now I've got those jaws defined on one side and the chuck, collet chuck defined on the other side. So now I can start doing all my programming that I need to do. In this case, I have one already done. So in here, I'll go ahead and just verify everything in the machine simulation so we can see everything working all at once. And I'll go ahead and launch simulation. And now you can clearly see the defined chuck in here. It's not a generic chuck anymore. All the jaws and the collet as well. Collet chuck. If I push play, I'll go ahead and run a few toolpaths just to give you an idea. Here's the Pickoff-Cutoff. So you can see everything being ran. And we'll talk about this rope turning here in just a bit. So I'll go ahead and stop it right there. That's pretty much it. When it comes to solid work holding, you're able to use solid models now to create your work holding. In the normal lathe side, when you go to create jaws, you're now able to use the solid jaws as well. So let me bring that up real quick. There we go. So this is a normal lathe seat. And in the stock setup, when I made these jaws, instead of using the parametric setting, I use the solid entity. So with aside from the chain now, you have the solid entity as well available to you. So you can see there is my jaw. You don't need the chuck, but you get the jaws at least. You can do this with the collet as well. So with that being said, I'm going to talk about this last toolpath here that I got on the list, the custom thread. These custom thread toolpaths create any type of thread that's available. You got like these rope style threads, you got some Acme threads, different types of weird buttress deal, whatever you got going on in there. So this toolpath here will allow it to cut in that particular profile. So there's two different ways of going about it. So I made two different ones here so you can see the difference. If I go to my parameters here, you would go ahead and choose the particular tool you're going to be using. Offset numbers, all that fun stuff. Your axis combination is just going to be the normal lathe upper left. This is more of the mill turn side if you want to get a rotation and all that. But in here, I've got it based off of a chain shape. So if you look in my levels, I have this wireframe right here that I created. And that's the profile of the rope right here. All right, so you can choose that chain, and there's not really much you need to do other than tell it is it an inner and outer type of cut. And your pitch. So inside of this section, this is your roughing capability. So I did a number of steps, number of amount per cut. You know, you can choose one or the other in this situation, and then depth of cuts in there. The type of cutting direction you want it to be, you can choose. How much stock to leave when you're roughing. And when you go to finish it, the amount per step, depth of cut, number of cuts, all that fun stuff. And in this case, I said 0 stock to leave in here. Basic clearances, overcut amounts, start and end position. So you can choose that manually or type it in based off of wherever the part is. In this case, this is a multi-started, a double thread. So there's 2 starts in there. So I added that in there with the different options. I, rough each start and start from the furthest part. So tool inspection, if your post is aligned for it, you can add that in there. How much clearance between the first pass and the beginning. Different miscellaneous values. And I can go ahead and play this out real quick. I'll play it out after I explain the second one. The second style would be if you didn't have a chain, you can create a parametric style here. And in this parametric style, you have to define what type of shape you're creating. So you have a rope or buttress, square, trapezoid, all those fun different types. And you can define your major, minor, major diameters, your pitch, depending on what size you pick in here, what style you pick in here, will populate different sections for that. And you can preview it once you've typed that information in. You can see there's my style right there. There's my rope. So everything looks pretty good in here. It's the same parameters after that fact, but there's the difference between choosing chain and parametric. So let me go ahead and backplot these two, or verify all of these. So we'll go ahead and fast forward through this situation here. And then I can push play here, and this should start cutting really nice. I'll just go ahead and fast forward it. I slow it down, it really doesn't do much. In the mill turn Moxim, you can really see it cutting piece by piece. You can see there's a lot of passes going on in there. So just fast forward this. And there's our end result. That looks pretty good. So that is the new custom threading operation that exists in the lathe seat. You can use it in mill turn or lathe. Doesn't matter which seat you have as long as you have one or the other. I got a few more things, some little tips and tricks in here to show. Actually, before I do that, I can show you this lathe roughing that I did. Notice that there's no wireframe showing on here. So if I go to this geometry, when I made this, I used that 3D chaining. If I go to rechain all, and I click on the solid section, there's my 3D chaining. From there to there. Say OK. Of course, that's going to cause everything else to go dirty if I regenerate that, so I won't do that for now. But you get the tidbit.
Alex, so is that all you have for what's new?
Yes, for the what's new, that's pretty much all I've got in there. I can start talking tips and tricks if you want, or do you want to take over? It's up to you.
No, yeah, I was going to say we're at our originally scheduled hour right about now. So if people have to leave, feel free. but we know we'd probably run a little long with the extra tips. So if you want to stick around, feel free, and Alex will start getting into some additional tips. If not, like I said, it'll be up on our YouTube channel later. But yeah, keep going with the tips and tricks now. Thanks.
Okay. All right. So if you got any questions, you can shoot us a message here, or you can email us, whatever you got in a later date. But let's go ahead and start talking about some of these tips and tricks. The first one I'm going to talk about is using stock models to redetermine the stock situation in here. And Matt kind of touched on this a little bit with the ones he did, but this is a little bit more in depth in this situation because some people, when they go to start big, sections that have big holes in it, it's a giant bore, you'll go in there with an insert drill, cut that out, and then bore it out. Well, sometimes that insert drill is a live tool. So when you use any type of milling, drilling functions inside of the lathe seat, you notice if I step through this, there's no stock removal at all. You don't see anything happening. So a lot of people get frustrated with that because you're not able to go and program the boring cycle. If you go and program a boring cycle to go finish off the rest of the material, well, it sees the entire stock is still there. So that's a very bad situation going on in there. So what we can do is when you can create a stock model of that particular operation, and in these parameters, you're able to select this section here that says create stock boundary. Once you check this box, it allows, let's show the next operation here. I'm going to move the history down so you can see. Once I create that box, you can see now there is a hole showing my stock removal. Versus before that, there's no hole. Even though the operation exists, there's still no update. So using that stock model to help you update that section is very useful. And then I can go ahead and start programming the rest of it. There's my rough operation with the boring bar. That works pretty well. So once you get the complete part made, another nice little tip you can do, if you want to see, if you've been running nothing but wireframe and you don't want to create a stock model, you can create a solid model based off of a preview. So if I right click in this white space inside of the tool manager, there's a selection here for lathe stock preview. So if I click on that, that's going to bring up my finished part with all the tool paths. I have a 3/4 section view I can use in here to view the inside if I wanted to. All right. And maybe I don't want to see the chuck, or I do want to see it, everything that you have defined inside of the space at the time will show up. And you can see per operation. So if I go to the original, there's the first stock there. If I say next, there's that first drill, there's the rough, there's the finish, there's that, and so on and so forth. If I click on final, there's my final product. If I want to keep this, let's say I want to keep the whole solid because I didn't have a solid before, I can turn off the 3/4 view. I can say keep geometry, and I'll say OK. So now there's two different solid entities in here. These are all created based off of the toolpath's cutting ability. I created this level before I made that because whatever level you're on is what it's going to be on. So it even creates wireframe. You can see this wireframe right here for this model based off of what it analyzed. So I can still turn that off if I wanted to see my original section. So that's a nice little gimmick in there. A lot of people don't know about that. Those two tips right there are really handy. The last thing I'll talk about is align to Z. And a lot of people know about it, but I do like to talk about it just in case because it is a very, very nice thing to have. Let me grab that real quick. So if you ever have a part that comes out like this, and it's all kinds of messed up, I'm going to put some curves on edges with this as well, just so that way some other things will happen here. To align this can be pretty nightmarish if you're not comfortable with using the transforming operations in here. So we can go to our model prep tab, and we can click on this button called Align to Z. So if I click this Align to Z button, what it allows me to do is select this solid on the closest axis that I want to be the front face of the part. So let's say I want to start turning, I want my jaws to be right here, and I want to start turning on this side. I would select any rounded section, so like this face here, that edge right there, anything of this situation that allows it to pierce through a Z center point. So I'll click this guy right here, and you'll see all these axes are all over the place, but the one you want to pay attention to is this Z and the X, right? So right now, as it stands, if I'm looking from a top view, there's going to be my Z and my X. Now, if this flat would be at that angle, particularly when I finish it. So maybe I want to rotate that X right here, just so that way everything's aligned properly to that flat. So maybe I want to rotate it, I'll find myself a quadrant that exists in here somewhere. If it's there, right there. So shifting that a little bit more is going to allow it to be a little bit more flat. Pretty sure that's all flat together. Then I can say transform to a plane, and we'll pick our top plane here. Now, the mask thing, this will only move the solid. It won't move that wireframe. So if I go in here and I said add additional geometry, I can go here and just window select everything except for the solid. There's my geometry, 1, 2, all those wireframes. So if you have things already built on it, or a fixture or something on there that you have, you can go ahead and add that in there and just say green check mark. And now everything is built in. The same spot, ready to go, ready to turn. So just a few overviews. Nice things in the normal lathe seat is you can go and create chuck jaws using your solid entity now, right here. Picking that file. Just to give you that example again real quick. Select our back face. Rotate 90. And say OK. So now I have that chuck jaw defined. So that's pretty much all I've got. Does anybody have any questions for me or Matt? Matt, I can't see any questions that have been coming through, if any. So
that's right. The only one we've had is, and I answered it, but where do you find to add stock models? But I said it's just there on the turning tab under stock model. If you have a milling license, it's on the mill tab as well. It doesn't really matter which one you pick.
Yeah. Well, that's pretty much all I've got in here. We can take more questions if you have any more, but I think we covered a good amount of stuff already.
Okay, Marvin just asked, where do you find that solid chaining function?
So whenever you have, whenever I go to create a turning operation, like let's say I go to create this finished operation right here, right? If it's not already showing right here, you just go to your solids tab and it will bring it up as such. So I can go and chain from there. So let's say right there.
So yeah, and if you have a solid and there's no wireframe at all, it'll automatically default to solid chaining. But if you have solids and wireframe, it'll probably start
might
out
be.
with wireframe, and you got to switch
Wireframe.
solids.
Yep, and then here's that dynamics situation here. So if I go and just bring it to about there, that's where the toolpath will end up stopping, most probably. Let's see if I can make it behave. There we go. Stop midway through that profile. See how it stopped right there? This is supposed to go all the way up to about here, and I had it stop there. I didn't put any dips in there, so it didn't dip down. But you get the idea with the chaining. There's that stopping point.
Appreciate everyone's time as always. But everyone have a good rest of your day, and we'll talk to y'all soon. Thanks, Alex.
Yep, no problem.